day, guys. This is your tutor engineer. Today we are continuing with a series on geometry. Let's start with today's lesson. PQRS is a kite. The diagonals are intersected T. QS is 24 centimeters. PT is 5 centimeters. TR is 16 centimeters. So let's just choose a color for that. So basically, QS is 24 centimeters, then PT is 5 centimeters, TR is 16 centimeters. Okay, so now let's calculate the area of PQRS. So the area of a kite is half the first diagonal multiplied by the second diagonal. So we know that the first diagonal is QS, which is 24 centimeters. Then the second diagonal is PR, which will be PT plus TR. (21 centimeters). So to calculate an area, it's half times QS 24 times PR 21. Then the area will be 252 cubic centimeters. Okay, that's the answer for 8.81. Now let's go 8.82. Calculate the perimeter for PQRS. So the perimeter for a kite is going to be QP plus PS plus SR plus QR. So we know that the kite is the same on either side. It's asymmetrical. It's symmetrical. I'm sorry about that. So let's try and find out the size. If you can find this length and that length, then we'll be able to answer the question of the perimeter. So let's calculate QP. QP is something like this. Okay, this is going to be T. Okay, so this length here is 5 centimeters. And then here you'll have 12 centimeters. So QP, you know that since this is a kite, that one is 90 degrees. So I have 90 degrees here. You can calculate QP by a theorem of Pythagoras. So 25 plus 144, 169. Then QP, square root sign on both sides. QP is 13 centimeters. Okay, so we can do the same thing to calculate QR. So now let's calculate QR. We know that the other half of a kite, the lower half, is also 90 degrees there. This length has been given. Now it's QR, that one is T. So now let's calculate QR with the theorem of Pythagoras. So QR squared is 400. So if you want QR as a length, you take a square root sign on both sides, then you're gonna get 20 centimeters. Okay, now let's calculate the perimeter. So we know that if we can get those two sides, and then we'll be able to sort out the perimeter. So QP is equal to, let's just choose a different color here so that our answer can be kind of distinguished. So QP is the same as PS in length. So we're going to say, since QP is 13, I'm going to say 13 times 2 plus SR is the same as QR in length, 20 times 2. So the answer there will be 66 centimeter will be our perimeter. So that's it for this question. Let's go to the next question. In the sketch below, prove that triangle BDE is similar to triangle BAD. So let's choose a color. So what do we have? We have DE is parallel to AC, which means D1 is equal to angle A. The reason for that is corresponding angles. Same thing with E1 is equal to angle C. The reason for that is corresponding angles also. And then angle B is a common angle for both triangles. Therefore, we can conclude, since we've met three conditions of similarity, triangle BDE is similar to triangle BAC. The reason is all the angles, angle. So that's it for this question. Let's go to the last question for today. In the sketch below, triangle ABE is similar to triangle DEC. Calculate the length of AB. We've already been given similarity, so to calculate the length of AB would be easier. So let's first find a scale factor. So a scale factor will be, we know that the length of ED is 8 plus 6, which is 14. We can divide it by the length of EC to get the scale factor. So here you'll have 14 over 8. The scale factor is about, 14 divided by 8, 1.75. Okay, so now it's going to be easy to calculate length AB. Since it's the bigger triangle, we're going to multiply length ED using proportionality times the scale factor. So AB is equal to ED, which is 5 centimeter, times 1.75. So AB is 8.75 centimeters. Okay, that's it for today. Stay tuned on the next video on geometry. If you like my video, please subscribe. I will talk to you again on the next lesson. Cheers.